Hello ladies and gentlemen, welcome to today's video. Today's video covers solving right triangles. So the objective, as you can probably guess, is to solve right triangles. First thing I want to talk about is what does it mean to solve a right triangle? Well, solving a right triangle means that you calculate all sides and angle measures. That's what it means to solve. So in today's video, I'm going to give you a few problems. You're going to have to find all three angles and all three sides within that right triangle. This is going to put together everything that we've learned from this chapter so far. Pythagorean theorem, trigonometry, special right triangles, all of that is going to be put within today's problems. So before we jump into a problem, I just want to talk about the methods that we have to find missing sides and angles. Okay, so on the left, you're going to see ways to solve for missing sides. The first way is the Pythagorean theorem. Leave yourself some space. Second way is to use trig. So to set up a sine, cosine, or tangent ratio. And then the third way is to use special right triangles. Okay, so these are three ways that we have to solve for missing sides. But you're not going to be able to use any method that you want in every problem. Sometimes one method may be appropriate and sometimes another method may not be. So for example, in order to use the Pythagorean theorem, we need two sides. So if you have a triangle where you only have one side and you're looking for two others, you're not going to be able to use the Pythagorean theorem. So for trig, you need one side, and then you need one angle. And then by special right triangles, what I mean is using a 45, 45, 90 or a 30, 60, 90. So special right triangles are a very special types of triangles. So as you can probably guess, this third method is not going to come up a whole lot. It's not going to be applicable a lot. It's not going to be very often that I give you a triangle that's a 30, 60, 90 or a 45, 45, 90. So in today's video, we're going to focus on these first two most. So that's the ways to solve for missing sides. Now looking at the ways to solve for missing angles. First one that we can use is use inverse trig. Okay, so again, setting up a sine, cosine, or tangent ratio. And then the second way that we can use is that a triangle sums to 180 degrees. And those are only two methods this time around. So again, I want to write down what do we need for this. So in order to use inverse trig, we need two sides in that triangle. And then to use the fact that a triangle sums to 180, you're going to need two angles. So I know this is a lot of information, and it's stuff that you already know, but what's really important about today's video is figuring out which method is best to use to solve for a side or an angle. So I think it's best if we just jump into our first example. So our first example, this one right here on the left, is when we are given one angle and one side. So in this case, you're going to notice we have two sides to solve for, and then we have a missing angle. So we have this angle right here we need to solve for. We need to solve for side PQ, and then we need to solve for side QR. So I'm going to start with solving for that last angle. Now this should be pretty easy. In terms of looking for angles, we can either use inverse trig or the fact that a triangle sums to 180. Well, that one's pretty easy. If I already have two angles, I can easily find the third one. If I take 180 and I subtract 90 and I subtract 37, I get 53. Okay, so that tells me that my angle P is 53 degrees. Okay, besides angle P, I have to solve for side PQ and I have to solve for side QR. Okay, so in terms of solving for missing sides, I can either use the Pythagorean theorem. Well, in this case, the Pythagorean theorem is not going to apply. I only have one side. I can't do the Pythagorean theorem with only one side. Now, could I use trig? Well, for trig, I need one side and one angle. In this case, you're going to notice we have one side, we have one angle. So we could use trig. Now, we can't use special right triangles to find the missing sides because this triangle is not 45, 45, 90, and it's not 30, 60, 90. So in this case, we're going to use trig to find the sides. Okay, so I'm going to have to do trig twice, once for one side and once for the other side. Now, if I'm looking for side QR, so that side right there, QR, I need to set up a trig ratio. I'm going to notice I have 22, which is the hypotenuse, and then I have side QR, which is the adjacent side. So if I write down my SOHCAHTOA, adjacent and hypotenuse is going to be cosine. So I have the cosine of 37 equals, my adjacent side is QR, so I'm going to write QR, although you could write X if you wanted to, over the hypotenuse, which is 22. Now this is something that we've solved before. Remember that cosine of 37 is a number. So I'm going to put this over 1, and then we do cross products. QR times 1 is just QR, and then I have 22 times the cosine of 37. You can just do that in your calculator. When you do, you get QR to be 17.57. Okay, so I'm going to write that up here, 17.57, and I'm also going to replace it on this last side. Okay, so now we have to solve for side PQ. We have two options. We can either do Pythagorean theorem, or we can set up another trig ratio. Now, if we use Pythagorean theorem, it's going to require us to use this 17.57 that we solved for. Now let's think, if we solve for that side incorrectly, and we use Pythagorean theorem, then we're going to find PQ incorrectly. So Pythagorean theorem is probably not the way to go. Again, because if we found QR wrong, then using Pythagorean theorem will help us find PQ wrong also. So instead, we're going to set up another trig ratio. We notice that PQ is the opposite side. So opposite, and then using that 22, the hypotenuse is going to be sine. So I have sine of 37 equals my opposite side, which is PQ, over my hypotenuse, which is 22. So when possible, please try to use the information that you were given originally. So what I mean is, I don't really want to use this 53, and I don't really want to use that 17.57, because if I found them wrong and then I use them to find something else, that other side or angle that I find is going to be wrong as well. Okay, so doing cross products on our proportion, put that over 1 and then do cross products, we get PQ equals 22 times the sine of 37. In your calculator, when you do that, you get PQ equals 13.24. Okay, so that's what it means to solve a triangle. We now know all the sides, all the angles. Okay, before we move on, I want us to check this answer and just think, does it logically make sense? So to do that, we're going to use some information back from Chapter 5, I believe it was. In Chapter 5, we learned that the smallest side is across from the smallest angle in a triangle, and the largest side is across from the largest angle. So in this case, my largest angle is the right angle, which is across from the largest side, which is 22. My smallest angle, 37, is across from the smallest side. And then therefore the medium angle is across from the medium side. This means that our answer checks out. Our answer makes sense. Okay, so that was the first problem. I'm going to do another problem with you, just so that we get the hang of this again. Okay, so in the triangle to the right, there's three things that we need to find. We need to find angle T, we need to find side TA, and then we need to find side TR. Okay, so I'm going to start with angle T. I normally like to start out with the object that I only need to find one of. So in this case, I need to find one angle and two sides, so I'm going to start out with that one angle. Now, if I know two angles, I can find the third angle just from subtracting from 180. So if I take 180 and I subtract that 90-degree angle and I subtract the 24-degree angle, I find that my last angle is 66 degrees. So angle T then is 66. Okay, so now we're down to finding two sides. If you are looking for a side, there's three methods that we wrote above. First method is Pythagorean theorem. Well, in this case, I can't use Pythagorean theorem because I only know one side. Next, I can use trig. I can use trig in this case because I do have an angle. So I have this 24, and I also have a side, which is 33. And then my last option is to use special right triangles, which in this case I can't use because I don't have a 45, 45, 90, and I don't have a 30, 60, 90. So in this case, I really only have one option, and that's to use trig. So what I'm going to do right now is I'm going to label all my sides with regards to that 24-degree angle. So that 33 is going to be the adjacent side, TR will be the opposite, and then TA will be the hypotenuse. So I'm going to start with finding TR. Okay, so to find TR, I have a 24-degree angle. I have the opposite side, which is TR, and then I know 33, which is the adjacent side. Now, if I have opposite and adjacent, looking above is tangent. So I'm going to get the tangent of 24 equals my opposite side, which is TR, over my adjacent side, which is 33. Now, if I put this over 1, I can do the cross products. So I get TR equals 33 times the tangent of 24. Now, remember, don't multiply 33 and 24. You want to do 24 tangent of 24, end your parentheses, and then multiply by 33. When you do that, you get TR to be 14.69. Okay, so next, after I find TR, I have one last side to find. I need to find side TA. Now, I'm going to label that TR on my figure before I move on. Okay, at this point I have two sides. So theoretically, I could do Pythagorean theorem to find that hypotenuse. I'm not going to do that because if I found TR wrong and I use the Pythagorean theorem, I'm automatically going to find the hypotenuse wrong. So instead, I'm going to use trig again. So I notice that my TA is my hypotenuse. So I have TA is the hypotenuse. And then I still have this 33 side, which is the adjacent. Now, if I'm using hypotenuse and adjacent, that's going to be cosine. So I have the cosine of 24 degrees equals my adjacent, which is 33, over my hypotenuse, which is TA. So again, put that cosine of 24 over 1, and you're going to do the cross products. I'm going to move a little bit. When I do that, I get 33 times 1, which is 33, equals TA times the cosine of 24. Once I divide by the cosine of 24, I get TA equals 33 over the cosine of 24 degrees. When I input that in my calculator, I get TA to be 36.12. So let's move back to our figure. TA is 36.12, and then let's mark that on the figure. Okay, so we have solved the triangle. We now know all three angles and all three sides. Before we move on, I just want to check, does this make sense? Is my largest side across from my largest angle? Well, yes, my largest side is 36.12, which is across from the 90. My smallest side, my 14.69, is across from the smallest angle, and then my medium side is across from the medium angle. So my answer does check out. It is extremely important that you check this every time. Is the largest angle across from the largest side, and is the smallest angle across from the smallest side? So this was the first type of problem that you're going to see when you're given one angle and one side. We're going to get another type of problem on the next page, so please flip the page. Okay, so here's the next type of problem that you're going to get. This type of problem is when you are given two sides. So in this case, I have a third side to solve for and two angles. So I need to find side PN, I need to find angle P, and I need to find angle N. Okay, so I told you with the last example that I like to start with the object that I only have to find one of. So in this case, I have to find two angles and one side, so I'm going to solve for that last side. Now I have a few different options. I can use Pythagorean theorem, trig, or special right triangles. So let's go through one by one. Can I use Pythagorean theorem in this case? Well, yes, I can. I have two sides. Can I use trig? Well, no, I can't use trig. For trig, I would need to have an angle. And I can't use special right triangles because I don't know that this is a special right triangle. So I'm going to have to use Pythagorean theorem to find Pn. So right up here, I'm going to write that I'm finding Pn. Okay, so we're going to use Pythagorean theorem. So a squared plus b squared equals c squared. C squared is the hypotenuse, which in this case is Pn. So that's going to be Pn squared. My other sides are 11 squared and 18 squared. Now, if I do 11 squared plus 18 squared in my calculator, I get 445 equals Pn squared. To get rid of that squared, I take the square root. So I get Pn to be the square root of 445. Now, if this were to simplify, you would need to simplify it. I can tell you right now that it doesn't simplify, so we are just going to leave Pn to be the square root of 445. Okay, so at this point, we are going to need to find those other two angles now. There's two options for finding angles. I can either use the triangle sum theorem, which says that every triangle sums to 180, or I can use trig, inverse trig. Now, it's important that every triangle sums to 180, but in this case, I can't use that fact because I only have one angle. So I'm going to have to use inverse trig. I'm going to start with finding angle P. Doesn't really matter what angle you find, but I'm going to find angle P first. Okay, so with angle P, if I look at the two sides that I'm given, 18 is not the hypotenuse, I don't know why I marked that. 18 is the opposite, and 11 is the adjacent. So opposite and adjacent is going to be tangent. So I have the tangent of angle P equals 18 over 11. Now, if you remember when we did this before, tangent and P are like a married couple. You can't just divide by tangent. So it looks right now like you're multiplying, but that's not the case. They're together. So we need to do something to break them up. Hopefully you remember that to be the inverse. So we do this tangent -1 on both sides, or the inverse tangent. So I have the inverse tangent of P equals the inverse tangent of 18 over 11. Hopefully you remember inverse tangent and tangent cancel. So you get P equals the inverse tangent of 18 over 11. Now, to get inverse tangent on your calculator, you do second tangent, and that -1 will pop up. And then you do 18 divided by 11, and you hit enter. Now, when you do that, you should get angle P to be 58.57 degrees. So angle P is 58.57 degrees. And then I'm also going to mark that on the figure. Okay, so then at this point we have one other angle to find. We have to find angle N. So in order to do that, I'm going to have to set up another trig ratio. I could use the triangle sum theorem, so I could take 180 and subtract 90 and subtract the 58.57. The only issue if I do that is that if I found angle P wrong, I'm going to find angle N wrong as well. So right now I'm going to find angle N, so I'm going to set up another ratio. Looking at the sides I have in relation to angle N, 18 is the opposite, or 11 is the opposite, and 18 is the adjacent. So again, I'm going to be using tangent. So I get the tangent of angle N is opposite, which is 11, over 18, which is the hypotenuse. So again, to get rid of that tangent, or to break up the tangent and the N, I take the inverse on both sides. So I'm going to take the inverse tangent of N. That's the inverse tangent of 11 over 18. So the inverse tangent and the tangent cancel each other. So I get angle N is the inverse tangent of 11 over 18. Putting that in my calculator, I get angle N to be 31.43 degrees. So angle N is 31.43 degrees. And I'm going to write that in my figure. Okay, so the whole trick with this section is just determining what is the best method to use. So you're going to see we used a whole bunch of methods. We used Pythagorean theorem, we used inverse trig, we used trig, we used the triangle sum theorem. So it's really important that you kind of analyze each situation carefully, and it's important that you check your answer. So on the question that we just did, let's check our answer. If we look at our figure, the biggest side is across from the biggest angle, the medium side is across from the medium angle, and the smallest side is across from the smallest angle, which checks out our answer. It's really easy to check your answer like that. If that did not end up being the case, so if the biggest side was not across from the biggest angle, then we would know that we did something wrong and we have to go back and fix our answer. Again, it's really important that you analyze each situation carefully to determine the best move next. So you have one problem to do before you come to class tomorrow. It's the subjective problem right here. So in this case, you are given two sides. So you have one side and two other angles to solve for. You need to solve for side UT, you need to solve for angle U, and you need to solve for angle S. So when you come to class tomorrow, I will be checking to see that you have this problem completed with all of your work. If you don't know what to do, go back and look at the example that we just did. This example is very similar because you are given two sides. If you have any questions, please bring them to class tomorrow. Good luck.